To make use of a Numpy package, we have to import Numpy like this. Import Numpy. And then we can use Numpy to check the version that we've installed on our machine by using the dunder method __ version _ like this. Then we press enter, and then this prints the Numpy version that we have installed on our machine. But then if we go with this, for every time we require Numpy, we're going to have to type Numpy in full. So there's another way of implementing this by using alias. So we can do import Numpy as NP. In many data science workflows, you're going to see this format of importing and using Numpy. So we import Numpy as NP, NP being an alias. Now we're inside the IPython environment, so which means we can use some magic methods in our workflow. For instance, we can do np dot, and then if we press tab, this gives us the content of our Numpy namespace. We can also do np ? And then this gives us a glimpse of the Numpy documentation. So if I press enter, now we get a glimpse of Numpy documentation. So Numpy provides an array object of arbitrary homogeneous items, fast mathematical operations over arrays, linear algebra, Fourier transforms, random number generation. And then here it says documentation is available in two forms: doc strings provided with the code, and a loose standard reference guide available from the Numpy homepage. So if you wish to learn more about Numpy, you can follow this link. So I'm going to go back to our IPython interpreter, and then I'm going to press Q. So this takes us back. Now, what we're going to be discussing in this tutorial is we're going to be looking at some of the behaviors and differences in the implementation and creation of Python lists and Numpy arrays. So to start with, we're going to create some Python lists, and then we're going to see how they pale in comparison with Numpy arrays. So we're familiar with this construct. Say list, L, list. So to create a list in Python, we call the list constructor, and then we can pass the range function or the range interpreter, and then we pass the number of items that we wish to create. Say, and then when we do L, sure enough, we have this. Now this is just a list of items comprising of digits, integer here. We can transform this into a string. We can do L2 equals, then we have our list comprehension. Then we can call the string method. Then we can say hi for hi in, we pass L here, and then sure enough, if you do L2, our list has been transformed into a string. Okay, now Python list allows us to have heterogeneous data types because Python is dynamically typed. So what I'm trying to say is we could have L3 equals, and then here we can pass different types in our list. We could start with a boolean, true, and then we could go with a float, 1, 4. We could go with a tuple, 2, 3. In fact, we could go with a comprehension, a dictionary like this, and then we could do something like type item. So we're inside our list dictionary, say for item in L3, and then this should give us a list of the different data types that we have inside our L3 list. So if I press enter, see, sure enough, we get a list of all the different types that we have here. Now, this is not very efficient when it comes to managing and manipulating data, because here we have different types, and then each of these different types is a complete object. So bool has Python object information, much like float, much like tuple, much like dictionary. So what this does is it's just more overhead for us when we are trying to manipulate or operate on these lists. So this is not very efficient for managing data. Now, we can create fixed type array in Python. So the way we do that is to implement with inbuilt array module in Python. So with that, we can create a homogeneous array type in Python. So to begin, we can do import array like that. So this array is an inbuilt module in Python, and then we can do py array, and then we can do array dot array. Okay, so then we can specify the type. So the type is integer like that. Then we can pass an array here. So if you look at our implementation thus far, we have L, so we can pass L here, and then just enter, and then we say py array. Okay, so now we have an array of homogeneous type. So you see, we specify the type, and then these are the elements of our array. This is a one-dimensional array, is it? Yeah, so if I do, no, I think that method is not available in, okay, we'll get there. But then this is just a one-dimensional array anyway. So this offers us a more efficient way of managing, manipulating data. But then it's still no way as efficient as Numpy. And we're going to demonstrate that in a minute. Now, watch this. If we do, so this is py array, okay. Now, we can create a NumPy array. We can do np, okay, let me store this, np array. Then we can do np dot arrange. Now, arrange is, what is it called? Arrange is similar to the range function in regular Python. So we can pass, so this is 10. Let's pass 10 here. So we're trying to compare and contrast these with this in terms of execution time to see which is faster and which is more efficient. So let's do this. Okay. Now, there is a magic method in Numpy that gives us the execution time of a single Python statement. So that magic method is known as time it. So this is how we write it. We write percentage time it, and then we can do, okay, py array, okay, let's be array 2. Then we can do py array, say multiply by 2. So this array we want to multiply by 2, and we'll also multiply this array by 2. So the same operation, we want to see the time of execution. Okay, so if I press enter now, what do we get? Py array multiply by 2. Okay, I think this took a while. So this is, we got 175 nanosecond plus or minus 5.34 nanosecond per loop. Then we got mean standard deviation of 7 runs, 10 million loops each. That's the amount of loops that ran to implement this operation. So 175 nanoseconds plus or minus 5.34 nanoseconds per loop, then like that. Now let's do the same for our Numpy array. Then we can do time it. Now we can do np array 2, so equals np array multiply by 2. The same operation. Okay, let's see. Enter. This is taking a while. It's taking a while. So what do we get? Okay, now we get it. See, we get 1.5 microsecond plus or minus 6.8 nanosecond per loop. Mean standard deviation of 7 runs, 1 million loops each. Now you can see the speed in comparison with this. The same operation, 1,000 loops, fewer loops for much lesser time, 1.5 microsecond plus or minus 68.8 nanosecond per loop. Now this ran, what is it? This ran 10 million loops each. And then look at the time it took. Let's try another one. We could have P array, and then we could have a list, and then we can pass range method here, and then let's pass 1 million here, underscore 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 underscore, like that. Now the Python interpreter, we ignore this underscore and just interpret it as 1 million. So the underscore is just for readability. So we can have this, and then we could have np array this time. Then we can have np.arrange, and then we can pass 1 million here as well on this, like that. Okay, so here, and then we can use our magic method, time it, and then we can have let's do for p array 2 is equals to p array multiplied by 2. Let's see the time of execution. Okay, now we have 19.5 milliseconds plus or minus 111 microsecond per loop. Mean standard deviation of 7 runs, 10 loops each. Just in case this didn't register, I'm trying to re-implement it like this. So 10 loops each. Now let's do the same thing with our Numpy array. So we can do time it, and then we have np array 2, np array, array 2 equals to this. Okay, so we're multiplying this np array by 2. It's the same operation. Let's press enter. Now this does 100 loops, mean standard deviation of 7 runs. Now for the same operation, we get 3.51 millisecond plus or minus 158 what is it called, microsecond per loop. and this does 100 loops each. Hopefully you get the idea. Okay. Now we can create a Python list. No, we can create what is it called? We can create Numpy array from Python list. We can also create Numpy arrays from the Numpy built-in routines. So to begin with, let's create some Numpy arrays from Python list. So the way to do that is we can do np.array, and then here we can pass a Numpy list. So if we do 1, 2, 3, 4, 5, 6, we'll press enter, so we get array 1, 2, 3, 4, 5, 6, like that. This is a one-dimensional array. Okay. Now this is homogeneous type, so this is our integers, right? Now we can specify explicitly which data type we want. So for instance, we can do np.array, and then we pass our list inside. So let's say we do 2, 4, 6, 8, 10, and in here we can do d type. So d type, if we set this to float 32, then we press enter, say we get an array. Say Numpy array is homogeneous data type. So we have 2.0 to 4. Whatever, because now we set the data type to float 32. Yeah, that's because where Numpy array or an array in general, at the implementation level, it's a single pointer pointing to a contiguous block of data, which helps us to manipulate and manage our data efficiently. Okay, now what if we try to create an heterogeneous type in Numpy? Say we do np.array, and then in here we pass something like 2, then we pass 3.14, we pass 2.6, we pass 7, we pass 9, we pass 10. Let's see what we get here. We didn't explicitly set the type. Now we've passed heterogeneous types here. We've passed float and integer types here. So let's press enter. Now you see what we get. Numpy, we upcast these elements we have inside of our list to create an homogeneous type in our Numpy array. So you see that all of these have been upcast to float type. Okay, now we can do one more because all of these are all one-dimensional array. Let's try to create a two-dimensional array. So we can do np.array, and then in here we can pass a list comprehension. Then we can do range I, then we can do I plus 3, then we can do for I in, now we have to pass a Python list. So let's say 5, 7, 9. Now let's see what we get. Now we get a two-dimensional array that is of 1, 2, 3, 3 by 3 shape. So this is a 3 by 3 two-dimensional array. So in case you don't know what is happening here, what we're saying is create a 3 by 3 two-dimensional array with each row comprising consecutive integer values, starting from 5, 7, and 9. So you look at the first row. The first row starts at 5. 3 consecutive integer values. From 5, we go to 6, we go to 7. The second row starts 7 here. 3 consecutive integer values, 7, 8, 9. And the last one like that. Okay. Now you look at all of these, like the implementation is it's quite verbose. So we can create numpy array also, but this time instead of passing Python list, we can use numpy built-in routines to create our numpy array. So let's do that. Let's create some numpy arrays from the scratch. So we can create, for instance, we can create a numpy arrays comprising of zeros. So to do that, we can use np.zeros. So that's the zero method in numpy. So then we have this. The first argument is going to be the size of a array. So if you do 10, then we can set the data type. So d type, you set that to integer, like that. So if you press enter, now we have an array of 10 values, all integers, like that. We can implement the same, and also we can implement something similar, but this time we can set the shape of our array. So let's say we wish to have a an n-dimensional array of comprising of ones. So we can do np.ones, for instance, and then here we're going to take some arguments. So the first thing we're going to do, say we want to pass the shape of our array, then we can do here, we can do, okay, so this is not quite working. So we can do, let's say 3 by 5, like that. And then here we can do, let's say the data type now. Let's say we say data type to be float now. D type is equals to float. Okay. So if I press enter, good. Now we have 3 by 5 array of data type floats. So here we have 1 point, 1 point, 1 point, like that. So np.ones, the values are ones, but the data type is float. So we have 3 rows, 5 columns, 1, 2, 3. Then we have 1, 2, 3, 4, 5 columns, like that. Okay. Now we can also create an array comprising of a single value. We can also set the shape of our array. So we can do, for instance, np.full, and then the first thing we can specify the shape of our array. Maybe we do 3 by 5, like that, and then the value that we wish to populate our array with. So let's say we do 3.142, like that. So this, if you press enter now, let me press enter. Okay, so now we have an array that is full of these values, of this value, and then the shape of a array 3 by 5. So this 3 rows, 1, 2, 3, 5 columns, 1, 2, 3, 4, 5, like that. We could also we could create what is it called? Let's say we wish to create an array that is filled with a linear sequence. So we're gonna pass 3 arguments. The first argument is going to be the starting value. The second argument is going to be the ending value, and then the third argument is going to be the value with which we step by. So what we're about to do is quite similar to the built-in range function in Python. So what I'm trying to say is this: we could do np dot arrange. So arrange in NumPy is similar to built-in range iterator or range function, if you like, in Python. So here we can pass our 3 arguments here. So if we do 0, we do 20, and then we do 2. So this is saying begin 0, end 20, step by 2. But of course, in our range function, it's always one step before the final value. So we don't expect to see 20 in our result. So if I press enter, sure enough, we get our array, and it steps by 2, and it terminates at 18, like that. Okay. Now, there is more we can do. For instance, we can create an array of specified values, and we can evenly space those values out between 2 values if we like. For instance, say we wish to create an array comprising of 10 values, and we wish to space those values out between 0s and 2. How do we go about it? Then we can do np dot line space, like that. And then here we can do 0 between 0 and 2, and we wish to have 10 values. So if I click enter, sure enough, we have a array between 0 and 2, and we have 10 values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Okay. Now, we can also create an array of a specified shape that is uniformly distributed. And then we can use some kind of random values between 2 specified values. Okay. The way we do that is to call the random method. So we're going to change random twice in Numpy. Okay. So for instance, say we wish to create a 3x3 array of uniformly distributed random values between 0 and 1. We can do, for instance, np.random, and then we're going to specify our shape here, 3x3. So press enter. Okay. Now we have a 3x3 array of number values, like so. Now we can also create a specified shape of an array. You can create an array of a specified shape that is normally distributed random values. So we can specify our mean, and we can specify our standard deviation, for instance. What I'm trying to say is we can create a NumPy array and of a specified shape, and then we can specify, or we can set the mean and the standard deviation of array integers in the course of our creation. So what I'm trying to say is we could have, for instance, np.random random.number. Okay. So now we want to specify. The first thing we do, we can specify our mean value. So let's say our mean value, I don't know, this is 0. And then our standard deviation, let's say 1. And then we need to specify the shape of our array. So if we do array, let's say 3x5. So that's the shape of our array. Okay. So if we press enter, now we get a 3x5 array. And then the values there have mean of 0 and then standard deviation of 1. Now, we can also create a NumPy array of random values, and then we can set our interval. We set our interval, we set the shape of our array. So for instance, if we wish to create an array of interval 0 to 10, okay, so we wish to create a NumPy array with values from 0 to 10, and then we can specify the shape of that array. So the way we go about it is to do np.random.random int. Okay, so let's say we wish to go from 0 to 10. So we're going to get random values from 0 to 10. And then we can set the shape of our array here. So we have a tuple here. And then let's say we do 2, 4, like that. So 2 rows, 4 columns. So let's press enter. Now we have this 1 to 2 by 4 2-dimensional array, like that. Okay. We can also create an array of identity matrix. Yeah. For those of you who are familiar with matrix, you know an identity matrix has the same value across the diagonal. So from top left to bottom right, the same value all through. And then the way we do that is to use np.height, and then we can specify the shape of our array. So if you do 3, so this is going to give us a 3 by 3 identity matrix. So if you press enter, say 1, like this. So this is identity matrix. There is more we can do. For instance, we can create an array that comprises of uninitialized value. Okay, and then whatever value we get is going to be what already exists in the memory location at that at that point in time. So let's see, what we're about to do is known as arbitrary garbage. So this generates arbitrary garbage values, if that makes sense. So the way we accomplish that is to do np.empty. So we need to pass we need to pass some kind of a arbitrary value here. So if we do 3, now press okay, so we get 1 point, 1 point. Let's do it again. We may not necessarily get the same thing. Empty. Okay, I think we still get the same thing here, but then the idea of empty is to create an uninitialized array of integers. So what we pass here is the number of integer or the number of values that we wish to get. Okay, so we're getting float here because I think the last thing we did in memory then was a float value. But in any case, I hope we get the idea. Now we're going to be talking about Numpy array attributes and then other concepts in Numpy in our subsequent tutorials. So we're going to stop here for now, and then we're going to continue later on. So guys, please like, share, and subscribe, and then I'll see you in the next video.